Okay, logarithms. For our first set of exercises, what we want to do is rewrite these into the exponential form. So right now, as it stands, these are in the logarithmic form or logarithm notation. Okay, so to basically put these into exponential form, this is what you have. So you have log base 6. Okay, this is important, the base. This is log, this is the base number. So what it means by base number is whatever is being raised. So basically we have 6 being squared. That equals 36. So this logarithmic notation is another way of writing this exponential. Okay, this is called your exponential notation. Here is your exponential. So log base 6 being squared equals 36. That's what this is saying. So here we have it written in the exponential form. So this next one, we have base 289. So 289 being raised to the half power equals 17. Okay, now as you recall from your rules of exponents that when you have something being raised to a fraction, say this 289 is being raised to the half power, what that's saying is the square root of 289 equals 17. Okay, the half power is a square root. As you recall, if I have a number x being raised to the 1/3, that's going to be the cube root of x. Okay, just keep that in mind as we're going along, that these fractional exponents are in reality roots. So that's what we get when we write this in the exponential form. We have 289 raised to the half power. This is log base 289. Log base 289. Here's your base number. Whatever it's equal on their side of the equal, that's going to be your exponent. So here we have this one, log base 14. So that means base 14 being raised to the negative second power equals 1 over 196. So in this case, what this one is referring to is that, as you recall from your rules of exponents, you have a negative exponent. A negative exponent means it's called the reciprocal. So basically that this equals 1 over 14 squared. Remember, when you have a negative exponent, it's a reciprocal. It's going to go in the denominator. Okay, once it goes in the denominator, that negative sign disappears. So this is your negative exponent, is your reciprocal. This goes back to your rules of exponents. Okay, so this next one here, we're saying that this is base 3 raised to the 4th power equals 81. We know that's true, right? 3 times 3 times 3 times 3. Well, that's 9 times 9. That equals 81. So that's kind of what we're doing here when we are rewriting the logarithm form into exponential notation. Logarithm notation into exponential notation. Okay, let's go over a few more of these, and then we'll switch going the other direction. Okay, so let's try this one. Log base u 15 over 16 equals v. So if we were to write that in exponential notation, we know we have base u log base u. So we have u being raised to the vth power equals 15 over 16. Okay, if we have log base v, u of u equals 4. We're saying that's v raised to the 4th power equals u. Okay, remember this is your base number. Whatever's next to this word log, it's usually written kind of down low or small. You see it's small. That's your base number. Your base number, this is your base number. This is your exponent, your exponential. So if I have log base 7/4 x equals y. To rewrite that, I have the base is 7/4, so I'm going to say 7/4 being raised to the y, that equals x. Okay, if I have log base 2v equals u, what that's saying is 2 being raised to the u power equals v. Okay, once again, this is your exponential notation. This is your logarithm notation. Okay, kind of the reason why we're doing all this is, as you recall from maybe earlier in algebra, we were doing stuff with x squared, x cubed, x to the 4th, x to the 5th, and then they say, okay, x equals 2. And then you go about solving these, right? Okay. So what we're doing different now is, instead of having x, your variable, as your base, what we're now doing is we're putting x as your exponent. In other words, kind of what we're doing when we're getting into exponential equations is we're saying 2 to the x, 3 to the x, 4 to the x, 5 to the x, and then we say x equals 2. So then you have 2 squared, that's 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So instead of having x squared, now we have some number. Doesn't matter, it could be anything. 15 raised to the xth power. So instead of having x as the base, we're now having it as an exponent. And that's kind of the difference of what we're doing when we're going into exponential type equations. Is we're no longer having x as a base. We're now kind of using it as an exponent. And it makes a difference when you're graphing it. But before I get sidetracked into this, let's just keep going through these exercises. I just kind of wanted to put that as a side note for you to kind of get basically an understanding of the difference of just, your x squared, x cubed, and the difference, and then you're having x as an actual exponent. Okay, so what if we have log base u v equals -16? So what that's saying is u, there's your base, being raised to -16 equals v. Okay, what if we have log y of x equals -8? What we're saying is that's y to the -8 equals x. Okay, here's your logarithmic notation. Here's your exponential notation. Now we want to rewrite these exponential forms. We want to rewrite them into the logarithmic form. Okay, so here we have our exponential. We want to rewrite these. So we're kind of going in reverse what we were just doing. So here we have base 64. We know this is the base, this is the exponent, this is what it's being raised to. So here's the base. We're going to say log base 64, 8 equals 1/2. Okay, this next one, we have log base 12, 144 equals 2. Okay, this next one, we know we have log base 9, right? This is your base number. 80, this is supposed to be 1 over 81. 1 over 81 equals -2. Okay, that's saying that 9 raised to the -1/2 power equals 1 over 9 squared. Remember, you take this negative exponent, you put it in the denominator. This is your reciprocal function. Negative exponent is a reciprocal. Okay, this next one here we have log base 1/12 of 1 over 144 equals 2. Okay, so kind of the reason why we're doing these is that when you're doing the logarithm, basically what you have is, if I didn't know any better, let's say I had this one here, that if I had log base 64 of 8, okay, and the reason why we're doing this is because we don't know what the exponent is usually. So in your calculator, you'll type this in, log 64 8 equals. That's saying that you have base 64, but like I said, the exponent, you're not too sure what it is. So that's kind of the purpose of these logarithms, is to kind of work it backwards. You don't know what the exponent is. So that's what I was saying earlier, that instead of having x squared or x cubed, now you have some number being raised to the xth power. You know what it equals, but you don't know what this exponent is. So to do that, this is the whole purpose of these logarithms, is to calculate this exponent. So that's kind of the purpose of why we're doing this, is to calculate what the exponent is. And to do that, you're going to be using logarithms. Okay, let's do a couple more of these practice of rewriting these between exponential and logarithmic form. So this first one we see we have base u. So we're going to say log base u v equals negative 14. Okay, this next one we have log base 8 a equals b. Okay, this next one we have log base 1/5. You could put it in parentheses if you like. Y equals x. This next one we have log base 6x equals y. Okay, go ahead. If you need to put this video on pause to write these down, feel free to pause these videos at any time. Okay, two more. Let's rewrite these last two into logarithmic form. Here we have log base. Remember, this is your base number. This is your exponent. Log base 9 x equals y. Here we have log base b 123, that equals a. All right. Okay, let's go ahead and evaluate some of these expressions. So if we have log base 4 of 64, well, we don't know what that equals, so we need to evaluate this. So we're saying that means that 4 being raised to some number equals 64. Right? If I say log base 64 equals x, and I'm saying basically evaluate means solve for x. So now I have to think, okay, 4 to the first power, 4 squared, 4 cubed. Okay, 4 to the first power is 4. 4 squared is 16. 4 cubed, that's going to be 64. So then I see, okay, here I got 64. That's kind of what I was looking for. I was looking for 64. So then I realized that 4 cubed equals 64. So I'm going to go ahead and say x equals 3. Okay, that means that log base 4 of 64 equals 3. Okay, this is what we were solving for. That's kind of the purpose of these logarithms, is because we're trying to evaluate, we don't know what this exponent is. So these are exponential equations where the x is in the exponent, your exponentials, and we're evaluating. Okay, once again, we want to solve for x. So we have log base 6. So we know 6 is the base. It's being raised to the xth power, and that equals 216. So we need to figure out what is x, solve for x. So we're going to say, okay, 6 to the first power, that equals 6. 6 squared equals 36. 6 cubed, that's 36 times 6. That's 216. So we see that 6 cubed equals 216. And 6 to the x equals 216. Therefore, x must equal 3. Okay, so what that's saying is log base 6, 216 equals 3. Okay, what if we have log base 4 of 16 equals x? Solve for x. So that's saying that 4 raised to the xth power equals 16. So we say, okay, 4 to the first power, that equals 4. 4 squared equals 16. There we have it, 16. So x equals 2. Okay, that's saying log base 4 of 16 equals 2. Okay, if you were to do these, this is kind of how you'd put it in your calculator. This can sometimes be very difficult to evaluate, which is why they use a calculator to do these. But for these basic ones, so you could get the idea, we're solving for this exponent. We don't know what the exponent is. That's the whole purpose of these logarithms, is to solve for the exponent when we don't know what it is. Okay, here we have an interesting one. Log base 3 of 1 over 243 equals x. So we're saying 3 raised to the xth power equals 1 over 243. Okay, now kind of want you to realize this, that here it looks like we have this reciprocal, right? 1 over some number is its reciprocal. This is your reciprocal. So therefore we know that this exponent must be a negative number. Because remember, when you have a negative exponent, it's the reciprocal. So before we evaluate that, let's just go ahead and say, 3 to the first power, 3 squared, 3 cubed, 3 to the fourth, 3 to the fifth. Okay, we know this is 3. This is 9. This is 27. Okay, 3 to the fourth is 81. And 3 to the fifth is 243. So it looks like we have a winner here, 3 to the fifth. But we realize that this must be a negative number. So we're going to go ahead and say 3 to the negative fifth equals 1 over 243. Therefore, x equals negative 5. So what we're saying is log base 3 of 1 over 243 equals negative 5. Okay, just keep in mind that when you see these reciprocals, that you have a negative exponent. Okay, log base 5 of 125 equals x. Solve for x. So that's saying log base 5. This is your base 5. So base 5 raised to the x equals 125. So we have 5 to the first, 5 squared, 5 cubed. 5 to the first is 5. 5 squared is 25. 5 cubed is 125. Looks like we have a winner. Looks like we're going to say x equals 3. Right? 5 cubed equals 125. Therefore, we have log base 5 of 125. We're going to say that equals 3. Okay, log base 343 of 7 equals x. So we know we have the base is 343 being raised to the xth power equals 7. Okay, so we see here that this number is smaller, right? This is smaller. So this must be some cube. This must be some kind of root. Okay, this has to be some kind of root. So that means that this exponent, this must be a fractional exponent. A fractional exponent. Because, if we squared 343, well, we get a number a lot larger than 7. So we're kind of going in reverse here. So what we can do to pick this apart is we could find powers of 7. So we're going to go ahead and say 7 to the first power equals 7. 7 squared equals 49. 7 cubed, we're going to say that equals 343. Okay, 7 cubed equals 343. Okay. So that means that the cube root of 7 cubed equals the cube root of 343. So that means 7 equals the cube root of 343. And that means 7 equals 343 to the 1/3 power. Right? I could take this root, this cube root, and write it as a fractional exponent. So now it looks like we have it figured out. 343 raised to the 1/3 power equals 7. And that's what we're looking for. What number is this being raised to equals 7? So we're going to say x equals 1/3. Okay, to rewrite that, we're going to say log of base 343 of 7 equals 1/3. Okay, here we have another of similar type. So here we're saying that log base 64, remember he says log base 64, so here we have 64 is our base number, being raised to the xth power equals 4. So once again, we have this bigger number. We have some exponent, and we're getting a smaller number as our result. Therefore, we know that this has to be some kind of root. Okay? So to do this, we're going to attack this number 4. I guess this is the best strategy to do. We're going to say 4 to the first power. That equals 4. 4 squared. That equals 16. 4 cubed. That equals 64. So then that means that the cube root of 4 cubed equals the cube root of 64. Which means that 4 equals the cube root of 64. Or we could say 4 equals 64 raised to the 1/3 power. So we have x equals 1/3. Once again, x equals 1/3. So we're going to say log base 64 of 4 equals 1/3. Okay, last one for this set of problems before we get into simplifying. So we're going to say that this is log base 6, so 6 raised to the xth power equals 1 over 216. So once again, we see that this is a reciprocal. Okay, anytime you see 1 over some number, that means that's reciprocal. And to get a reciprocal, you need a negative exponent. So we know going into it that x is going to be a negative exponent. So let's see what powers of 6 will give us 216. So we have 6 to the first power, 6 squared, 6 cubed. Okay, 6 to the first power is 6. 6 squared is 36. 6 cubed is 216. So 6 cubed is 216. So we know that this must be a negative exponent because it ended up down here. So we're going to say that x equals negative 3. Okay, x equals negative 3. So therefore, log base 6 of 1 over 216 equals negative 3. Okay, remember, if I have 6 to the negative third, I'm saying that that's 1 over 6 cubed, which equals 1 over 216. Remember, this negative exponent, it means reciprocal. It's going to go in the denominator. That negative sign disappears. Okay, real quick, let's go over the simplification of something, if you see like this, 12 being raised to the power of log base 12 of 144. Okay, I want you to kind of see something here, that this is 12 and this is 12 here. So we have 12 being raised to log base 12. Okay, I'm going to say that this equals 144. Okay, I'm going to tell you that this equals 144. When you see something like this, remember, this is being raised to this power. This is being raised to this power up here. And the reason for it is this. If you evaluate, let's go ahead and evaluate this portion of it. So we have log 12 of 144. Right, that's saying 12 raised to some power equals 144. We know that that's going to be 12 squared equals 144. So we could say this equals 2, right? So this portion equals 2. So I could replace this with a 2. And then lo and behold, this statement ends up staying true. So it's kind of the idea behind this. So let's say I saw something that was like this. If I had 5 raised to the log base 5 of 171. Okay, I noticed that this is 5, the base 5 is being raised to a log base 5, right? Similar to the situation with the 12 and 12. So right away I know that this is going to be 171. Kind of a quick shortcut. So let's say I had 9 raised to the power of log 9 of 81. Okay, so if I wanted to just evaluate this portion of it, I'm going to say that that is 9 being raised to the xth power equals 81. And I know that 9 squared equals 81. So I could say log base 981 equals 2. Okay, log base 981 equals 2. Well, here's log base 981. So I'm simply replacing this with a 2. And what do I get? 81. So sure enough, when I have this 9 log base 9 of 81, I'm going to get 81. So just kind of a simplification shortcut. If you see this, you see that this and this are similar, it's being raised, there's your answer. And this is kind of why this works. So let's say I had this x being raised to the power of log x of 72. Well, I'm going to go ahead and say that that equals 72. Okay, anytime you see this situation here, just know this is your answer. Okay, I want to thank you for watching. Please press the like button, comment, and subscribe if you want to see more of these type of videos. Thank you.